Hello everyone, I'm Paul and today we're solving problem 812, largest triangle area. Here it says this is an easy one, but you need to know the formulas to solve this. Regarding programming, this is quite simple, so let's start. We are given an array of points in a plane, so let's say we are given this, and we need to return the area of the largest triangle that we can find. In this case, this is the visual representation for these points, and the largest triangle is this one. And the area for this triangle is 2, so we return 2. As you can see, this is basically a math problem. Regarding programming, I think the most important part is to realize that we can iterate every triplet of points, meaning we can iterate every possible triangle. Why? Well, because here we have the constraints and we know that points.length is smaller or equal to 50. So we can think in terms of n cubed, because 50 to the power of 3 is a number that we can handle. So now the question is, how do we find the area of a triangle? And we have a few formulas for this. We are given points in a plane. So first we need to get the sides of a triangle. So given 2 points, let's say this and this, we can use this formula to get this side. Once we have the 3 sides, we can get the area for the triangle with something called Heron's formula. You can Google this, but it's basically this formula. Here we have 3 sides, A, B, and C. And S is A plus B plus C divided by 2. This is the semi-perimeter, which is the perimeter divided by 2. So we are iterating every possible triplet, meaning every possible triangle with the points we were given. And at each step, we need to get the area for the triangle we are standing at. And we keep the maximum area, and this is what we need to return. So with this in mind, let's go with the code. First we say n is the length of points, and the result is minus infinity. And we need to return the maximum value, that's why we start with minus infinity. And now we can try every triplet, meaning every triangle. So for I in range n, for j in range from I plus 1 to n, and for j in, this is k, in range from j plus 1 to n. And here we can say x1, y1 is points I, x2, y2 is points j, x3, y3 is points k. And now we can get the sides for the current triangle A, B, and C, and this is the square root of the absolute difference of x1, x2 square plus the absolute difference of y1, y2 square. And we are doing the same for B and C. So B is this, C is this, and this is x2, x3, 2, 3, and this is 1, 3, 1, 3. So now we can get the semi-perimeter, which is the perimeter A plus B plus C divided by 2. And now we can get the area, which is the formula from a few minutes ago, square root of SP times SP minus A times SP minus B times SP minus C. And it might be a case that this is a negative value, And if we try to do the square root of a negative value, this will throw an error. So we will remove this from here, and we will store this in a variable. We'll call this value. And now for the area, we do the square root of the maximum among 0 and value. And finally, we update the result. This is the maximum among the result and the area. And finally, we can return result. So this is it for the code. As you can see, this is a math problem. Here time complexity will be big of n cube and space complexity big of 1. So let's submit this and see if it works. As you can see, this works and it's efficient. There are other solutions with different formulas, but the time complexity is basically the same. It's big of n cube. We need to iterate every triplet, meaning every triangle with the points we are given. So this is it. If you found this useful, please drop a like, subscribe, and see you in the next one. Bye bye.